IDS Peak is the software that is provided free of charge with all IDS cameras. This includes the necessary drivers, libraries, code examples, and documentation customers need to build their projects. It also includes Peak Cockpit, which is our core program for testing and evaluating our cameras, and in some cases can even be deployed as an end solution. This series of short videos will provide an introduction to Peak Cockpit from the basic startup, which we will cover in this video, through all of the parameter controls available, and to more advanced topics such as the generic parameters dialog and using chunk data. But first we need to know how to connect a camera and get started. IDS offers cameras with USB and Ethernet interfaces, and we will see the connection procedure for both. Firstly, with USB, we simply attach our USB cable to the camera. The other end is already connected to the PC, so we see the camera initializes and is ready once the solid green light is on. It is a basic point-to-point connection in this case, but the camera could also be connected via a USB hub or via USB fiber optic extender. If we switch now to IDS Peak Cockpit, we can see that the camera icon in the top left corner becomes active when our camera is available. We then have two options. We can either click on the camera icon, which opens our camera or the first camera available if we have multiple cameras connected, and immediately we see a live image. Or we can open the camera manager, the second button on the main menu, and especially on systems where multiple cameras are connected, select the camera we wish to open and either double click it or select the camera and click on the open camera icon. There are a number of other options here. At this stage, the only additional button we need to be concerned with is the information button. This shows specific camera information such as the device ID, the model, and the serial number. The others will be covered in other videos. For GigE cameras, the connection process is more in-depth as we need to set an IP address and subnet mask on the camera. Without going too deep into what this all means, the IP address is the address for a device, in this case our camera, on the network and tells other devices where to send data and communication, and the subnet mask defines the IP address range. We have the option to use DHCP, in which case the system takes care of the IP configuration, but takes longer to assign the address and needs to be done each time the camera is reconnected. In most cases, it is better to use a fixed IP address. However, this requires setting the IP address of the network card first and goes beyond the scope of this video, so is covered in a separate video specific to network setup. There is also information in the camera user manual for configuring camera IP addresses. Working with DHCP, first we take our camera and connect our Ethernet cable. If using power over Ethernet, we should see the status light start to flash green. When powering the camera from a separate power supply, we connect the Ethernet and power cables and again wait for the status light to start flashing green. In IDS Peak Cockpit, if the camera icon in the top left corner is enabled, the IP configuration was successful, and we can open the camera directly from here or via the camera manager as we did with the USB camera. Once we have connected to the camera, the status light will go solid green. With Ethernet cameras, it can also be a simple point-to-point connection, or we can connect to a network via an Ethernet switch, which can also provide the power to the camera via power over Ethernet. With the camera successfully connected, at the bottom of the camera dialog window, we can see some information displayed. There is the current frame rate, the number of images that have been acquired, as well as any incomplete images, which may be due to insufficient bandwidth, or reconnects to the camera if the cable is disconnected. And we can see the XY position of the mouse when it is moved over the image. Currently, the camera is running in continuous acquisition mode, which we can stop by clicking the Start Stop Acquisition button in the camera window, and the display just shows the last image. At this point, the button next to it becomes active for single frame acquisition, where a new image is updated each time the button is clicked. The image at first connection may be a little too bright or too dark, and if using a color camera, maybe the white balance needs some adjustment. For the best out-of-the-box image, we can click the Image Optimization button, which will enable auto features to provide optimum settings for the setup. This adjusts settings for brightness and contrast, color, and post-processing features such as gamma correction. And this can be performed as a one-time function or set to continuous adjustment. Two of the first sets of parameters that users tend to adjust are frame rate and exposure, and these two are interlinked. To adjust these, we click on the brightness frame rate button to open the dialog. We see at the top of this new dialog the frame rate adjustment. Here, as we adjust the slider, the frame rate of the camera changes accordingly, and we can see this reflected in the display and also the FPS status in the camera window details. It is also possible to set the frame rate manually in the text box. Linked to the frame rate is the throughput limit. This value determines how much bandwidth is available to the currently used camera. For a single camera system, we can set this to the maximum value. But for a multi-camera system sharing a single USB or GigE interface, we can adjust this value to configure how much of the total bandwidth is available to each camera. There's also a bandwidth management utility within IDS Cockpit that can be used to automatically calculate these values. Information on this will be available in a separate video. Underneath the frame rate setting, we have the exposure time control. If the camera is currently set to auto exposure, which may be the case if the image optimization is enabled, exposure time control will be disabled. So we have to turn off the auto exposure control below in the auto features section, or by disabling the image optimization. When enabled, as we increase and decrease the exposure time, we can see the image getting brighter and darker accordingly. At the moment, the option to limit exposure time by frame rate is enabled. This means that currently we can only set the exposure to whatever the frame rate allows. This is effectively 1 divided by the frame rate multiplied by 1000 to give us the exposure time in milliseconds. As examples, at 10 frames per second, the maximum exposure would be around 100 milliseconds, and at 40 frames per second, it would be around 25 milliseconds. For longer exposures, we can disable the limit exposure by frame rate option, and this will then allow us to set longer exposures for much darker scenes, as we see here. But the frame rate will be adjusted down accordingly. The last setting we will see in this video is that of the gain control. Like with exposure, if the camera is set to automatic, we need to disable this in the auto features section. And then depending on the camera model, we may have access to just analog gain or also digital gain. Adding or increasing gain will increase the brightness in the image. In short, analog gain boosts the signal in the sensor and is generally better for minimizing noise artifacts. Digital gain, which we would generally use when the analog gain is at a maximum, is performed off-sensor, either in the FPGA or in software, and tends to introduce more graininess in the image. But in the end, it is down to the user to evaluate these parameters to determine what works best for their application. That concludes this session. I would like to highlight that this information is also available in the Peak User Manual in Section C, Programming with IDS Peak, under Installed Programs and IDS Peak Cockpit.